Okay, so here's examples. All right, and we'll refer back to this. So decimal point 00456. Okay, so right off the bat, we know 456 following rule 1. Okay, all digits other than 0 are significant. So we know right off the bat that we have at least 3 here, okay? And if we look through here sort of quickly, see greater than 1, no. Decimal point is used after non-decimal number larger than 1. No. 0 placed after non-decimal point are significant. No, that's not it. Smaller than 1, all zeros placed before the significant figures are not significant. So the first one, we apply rule 6. All of them we apply rule 1, so apply rule 6. And we're going to have 3. So this will be 3. Okay? Okay, so the next one, 1.345. So we recognize right out the bat we have 4. But what about these 2 zeros? Are they significant? Well, if we go back and look and see what rule this follows, we'll actually find that it's rule 5. Okay? Placed after a decimal point and not necessary to set the decimal point are significant. So in this case, this one is going to be 6. You're going to have 6 significant figures. All right? About the next one. 13000. 13,000. Okay? So let's see. 1, we know that applies. No. 2, no. Okay. Greater than 1, all zeros placed after the significant figures are not significant. Okay? So in this case, number 3, we're going to apply, 1 and 3. So in that, we have 1 and a 3, and then we have these zeros. So these zeros are not significant. So there's 2 significant digits in this one. Okay. Now the last one is kind of the C and D are similar, except that we put this decimal point here. Okay. So if we go up, take a look. It's not 2. 1 is yes, of course. 2, no. Okay, doesn't follow that one. Okay, so if a decimal point is used after all non-decimal number larger than 1, the zeros are significant. Okay, so this one, number 4, applies to the last one. If that's the case, we're going to have 1, 2, 3, 4, 5, 6. So this is going to be 6 significant figures. Okay, and just a note is that the rules for significant figures is shown on page, it's on 54 and 55, and there's some additional examples in there for you to look at. Okay, so the next thing we have is significant digit math. Okay, so now that we have identified the number of significant figures in those numbers, what we're going to use is we're going to use that. And then when we perform our math, our end result will have the appropriate number of significant figures. Okay. So there's 2 basic rules for this. We have multiplication and division, and addition and subtraction. Okay. And here's the basic, main point of this. Okay. When we do multiplication and division, we need to make sure that the number of significant figures it has to be the final number that you calculate, or from your calculation, is going to have the number of significant figures of the number with the fewest significant digits. Okay, so if you have 2 numbers, one has 3 significant digits, one has 2 significant digits, and you do multiplication, the end result has to be that you have just 2 significant digits. Okay, and that's rule 1. This is shown in like example 3.2. Yes, 3.2 looks like. And there's another one, 3.3, that also applies for rule 2. Okay, so rule 2, if you're doing addition and subtraction, so it should only show significant figures only as far to the right as seen in the least precise number in the calculation. Okay? And so in this case, you have to line up the numbers. All right, so you have, you put the appropriate position or weighting lined up so that it matches with the the number above it. But there's an example, and it is 3.3 shows this, but I'll go through some for you briefly. Okay, so here's multiplication. So we have two numbers. We want to multiply them together. So how many significant figures do we have in this one? 1. So we know we have, these are between, zeros between digits. So we know these are significant. So this has 4, and this number has 3. So we just go ahead and perform the math, and then we recognize at the end that our end result should just have 3 significant figures. Okay, and what you do with the least significant figure, okay, or least significant digit, is that you're going to round up or round down depending upon the value of the next digit. Okay, so you would kind of look over here and say, oh, okay, if this is 5 or above, this becomes a 1. If this number is 4 or below that, this becomes a 0. Okay, and that's really all we need to do. All right, so pay attention to the multiplication division. It's the number with the 3 significant digits. And it might be that you're performing multiple operations, so you've got to just retain the number of significant digits every step. If you're doing addition or subtraction, then you retain the significant digits, and if you do multiplication, division, you've got to retain the significant digits as you go through it step by step. Okay. The second one. All right, now adding and subtracting. Now in this case, you could take and line these two numbers up, same two numbers. You put the 4 here, 0.67. So you know that just in terms of precision, you cannot have anything more than 2 digits, your result, not having any more than 2 digits to the right of the decimal point, okay? Because of these two here, right? And this is, 1/10, this is 1/100th. So the end result is, and like before, perform the math exactly with the numbers that you have at that point in time, perform the math. And then, this one has, because this really essentially is the limiter for this calculation. This one has 2 digits to the right, so your end result should have 2 digits to the right of the decimal point. And like this is shown, there's another nice example in example 3.3, right? So just like before, we look at the next digit, we see if it's 5 or greater, it's 5 or greater, we're going to round up this digit, okay? And that's essentially it. Okay. Now, here's some operations to perform, and if you want to pause this and see what results you get for these, then you can restart to see if it matches with mine. Okay, so for the first one, add these two together. What we recognize is our end result is going to have 2 digits to the right of the decimal point. Okay, so if you add these two directly, you come up with 2.105, but that's 3 digits to the right. So the last one, what we need to do is truncate it. So your answer should be 2.10. Okay. So the next one, 2 significant figures, and this one has 3 significant figures. When we do multiplication or division, it's going to be the result has as many significant figures as the number with the least number of significant figures. All right, so this one has 2, this one has 3, so 14 divided by 2.00 is going to be, could be 7.00, but we know it's only going to have 2 significant figures, so the end result would be 7.0, right? And the last one, this one here, 7.5 times 20 point. So this is 2 significant figures, 2 significant figures, and then the result's just going to have 2 significant figures. So when you perform this calculation, this is essentially 150 or 150. Okay? It's one way you can write it. You could also do 1.5 times 10 raised to the second power. It's another way to write it. But recognize that it's 150. There's no decimal point there, right? Okay. So 2 significant figures for that end result. Okay, and that's good for part 1 of the lecture slides. I'll put the part 2, which is the second part, the other sections 3.3 and 3.4 in part 2 of the lecture slides video.